Okay, another example. Okay, example number 2. Okay. Now, a 200 200-pound man hangs from the middle of a tightly stretched rope so that the angle between the rope and the horizontal direction is 5 degrees. Calculate the tension in the rope. Or now, okay, a rope 200 a 200-pound man hangs from a middle slightly stretch rope. Okay, let this one as the horizontal. Okay, you have your rope at the middle. Okay, okay, this one. Okay, hang down. Nagsag yung, there is a sag for the rope, 5 degrees because of the man. This one is 5 degrees. There, here. Okay. Therefore, the tension, you have the tension here. Let this one is your T1. Here you have your T2. That is the tension in the rope. Okay, for the free body diagram, this one is the free body diagram. You have your y-axis, x-axis for the, if that is 5 degrees, of course, this one is your tension. Since both have a 5 degrees, therefore this one, if this one is 5 degrees, of course, this one is also 5 degrees. 5 degrees. This one is your T1 and T2. T2. And free body diagram. Okay. If you notice your T1 is under the polar coordinates, hypotenuse and angle theta. If this one is under the polar coordinates, of course, you have your Cartesian coordinate, the X and Y axis. Okay. Since your T1 is lying on the first quadrant, therefore, we have your T1x, then we have your T1y. Also, your T2 is under the Cartesian polar coordinates. Of course, we have your Cartesian coordinates, the x and y. Okay, but your T2 is lying on the second quadrant. Therefore, your T2x is lying on the second quadrant. Wait. This one is your T2x. Then we have your T2y. Now, using the equilibrium, summation of forces at the x-axis equal to 0, positive going to the right, we have T1x weight, the weight of the man. You have also the weight of the man, this one, W, which is equal to 200 pounds. Now, from the given figure, this one, summation of forces at x, positive going to the right, equal to 0. You have your T1x minus T2x. Only your T1x and T2x are on the x-axis, equal to 0. Your T1x is equal to T1 cosine 5 degrees. And your T1y is equal to T1 sine 5 degrees. While your T2x is equal to T2 cosine 5 degrees and T2y is equal to T2 sine 5 degrees. Now, T1x, your T1x is T1 cosine 5 degrees equal to T2x, which is T2 cosine 5 degrees. Okay, therefore, T1 is equal to T2. Cancel, cancel. Therefore, T1 is equal to T2. Okay. Now, next, we have the summation of forces at Y. Summation of forces at Y equal to 0. Assumption, positive going upward. Okay. Forces at y-axis, you have T2y, T1y, and the weight. T2y plus T1y minus the weight is equal to 0. We have three forces lying on the y-axis. You have T2y, tsaka T1y, and the weight. Okay, since your weight is going downward, that is the reason we have negative W. Your T2y is T2 sine 5 degrees. T2 sine 5 degrees plus T1 y is T1 sine 5 degrees. T1 sine 5 degrees equal to transpose your weight to the other side. Therefore, that is positive, which is equal to 200 pounds. Okay, remember that we have the condition from your summation of forces at X. Your T1 is the same as T2. Okay. Condition, your T1 is the same as T2. Therefore, your T2 here is the same as T1 sine 5 degrees plus T1 sine 5 degrees equal to 200 pounds. Now, your T1, we have 2 T1. Therefore, the same 2 T1 sine 5 degrees is equal to 200 pounds. Where your T1 is equal to 200 pounds divided by 2 times sine 5 degrees. Okay, therefore this one, 200, use your calculator. Okay, therefore your T1 is equal to 1,147.37 what is the pounds. Therefore, if your T1 is 1,147.37, that is also the same as your T2. T1, since we have the condition that your T1 is the same as T2. Okay, therefore, that is 1,147.37.